Okay. So last time we talked about apa nama dia, projectile and free fall. So free fall ni dah jadi macam ancient lah. Kita sekarang into projectile. So projectile motion deals with two axes, right? We know that it has the x and the y. Mana gambar yang sesuai tu? It's not this one. Sekejap. The three examples too. Okay, it's this one. So we know that projectile motion, this is free fall. Okay, kita tengok ni lah. Okay, so projectile motion, we know that it has two components, ada x and ada y. So when we start with an initial velocity, you can actually resolve this into its components, ux and also uy. And then at this point, you reach the maximum height, and this is equal to v equals to 0. Whenever they ask you about the maximum height and your motion is up and down and you have this peak, right? You have that peak. Always assume this point will have v equals to 0. That is an information that will not be given to you, but you have to remember it yourself and apply. Okay, so when you apply v equals to 0 over here, your v equals to u plus at equation will be 0, and whatever this is, uy minus 9.81 and t, right? Your t that you solve will respond to the time taken to reach the maximum height. It will respond to the time taken to reach the maximum height. It's not the total duration of time. Okay, bila saya pakai equation ni, saya letak kat sini kosong, bermaksud anything that I get from here, which is the time is related to when I get v equals to 0. So when is it? It is when this guy happens. That is the time taken. Whatever the value of time that I get, that is the time taken to reach the maximum height. So if I know my Vy, let's say my Vy over here, okay, this is my V, therefore this is my Vx and this is my Vy. I have the value Vy something 10, let's say it's 10. So I put in here 10 equals to Uy minus 9.81 T. This T is now the T over here because I use the value 10. I use the value 10. Sorry, this should be minus 10. Minus 10. I use the value minus 10 because it's going down. I use it in my equation. Therefore, the time that I get from this equation will be the time to get the final velocity at this point lah. Okay, so it refers back to the values that you use. If you use 0, jangan cakap, okay, the time that we get here is the total duration. So that's wrong, eh? Okay, so I hope I'm clear on that. I think I've repeated this many times already. So I hope everyone is clear on this. And then what else? When we get the Vx and the Vy, we solve it using linear kinematics, right? We get the Vx and the Vy, and finally they ask you, what is the final velocity? Velocity is a vector. They don't want the Vx and the Vy. They're asking you about the velocity. So you have to find out what is the V. So the V is, using your Pythagoras theorem, Vx squared, Vy squared. So this will give you magnitude. Do not put in plus minus ke apa ke. There's no sign associated with this equation. It only gives you the magnitude or the value. To find the direction, the equation that you should use is the inverse tangent Vy over Vx. And remember, if you get a negative angle, that angle will be below the x-axis. Then if in this case, you should get a negative angle because your V is below the x-axis. So this is the theta that they are referring to. So when you answer the question, the velocity is, or you can say the final velocity, right? That is more accurate. The final velocity is 15 meter per second. Lepas tu angle dia 13 degrees below the x-axis. Boleh jawab macam tu, ataupun you can say 15 meter per second with minus 13 degrees. Boleh juga. So the minus refers to below the x-axis. Okay. What else? What else should we recap? And then again, your acceleration in the x is 0, acceleration in the y is minus g. And then always use your linear kinematics equation. Those are the 4 equations that you need to remember. Do not memorize other equations selain 4 tu. For example, jangan memorize equation for t in this case. Don't memorize this. Just use the linear kinematics and solve for time. This will not help you if you mess up somewhere. It's hard to trace it back. So just use the linear kinematics, okay? Alright, so kita dah cover symmetrical projectile motion. I hope everyone still remembers that. And then we already talked about non-symmetrical projectile motion. In this case, it was a projected horizontally from a certain height. Okay, this is another thing. The displacement, as I mentioned to you before, S y is equal to delta y. Kenapa macam makin kuat orang ni potong rumput? Saya tak tahu korang dengar ke tak. So this is y final minus y initial. So in this case, your initial is 100 and the ground is 0, right? 0 in the y-axis, and this is 100 in the y-axis. So your final should be 0 and your initial is a 100. Therefore, your S is minus 100. Please use this approach whenever you want to find out your displacement, whether it's negative or positive. I told you going up gives you a positive S, going down gives you a negative S. If you're not sure, use this equation. This is always valid to use. Okay, and again, delta always refers to final minus initial. Doesn't matter if it's time, doesn't matter if it's displacement, doesn't matter if it's velocity. Dia akan jadi final minus initial. Okay. So that is that. For this question, it says projected horizontally. It means that you only have an x component. Horizontal means x-axis lah. So it only has an x component in the velocity. The y is 0. But does that mean it will always have a 0 y velocity? No, because you have acceleration, which is gravity, going in the y. When you have acceleration value, it means that your velocity will change. So dia akan ada value lah kemudian-kemudian tu, either negatif ataupun positif. Sekejap. Yes. Okay. Kejap. Mommy is working. Kejap, where's my phone? You don't make noise. Okay. I think we already solved this one. So that was your recap for today. Any questions so far before we move on? Any questions about what we have done so far? Everyone's okay?
Okay.
Okay. Soalan any confusion? No confusion? Everyone's clear? Okay, kita move on Kalau ada boleh tanya. Okay, so another non-symmetrical projectile motion. In this case, kita ada this up and down motion, up and down. So kita ada peak kat sini, which means that we have that V equals to 0 at this point, right? Because dia ada up and down. Let me besarkan ni jap. Kita akan analyze this picture first. Let me get rid of this angles because it's not useful for us. Okay, so kita ada initial velocity of V0 equals to 20 meter per second. We know how to resolve this into its initial x and initial velocity in the x and in the y. So in this case, we have V0 with an angle of 30 degrees over here. Okay, 30 degrees. So if I were to resolve this, this would be ux equals to V0 cosine 30. Because why? The x-axis is touching the angle. So it gets the cosine. And then siapa yang tak touch the angle? In this case, it's the y-axis. So the uy gets the sine. So this is V0 sine 30 degrees. Okay, so this is our first step. So kita ada that motion up and down tu kan, and I told you if you have that up and down, it is equal to 0. Kejap, Lisa, can you go out please? Thank you. Yeah, later, okay? Later. Okay, lepas tu dia tengah main game Minion Rush. Don't know if you guys know that game. Thanks, baby. Okay, so his favorite game is Minion Rush. So it's very noisy. So I tak tahan. Okay, so moving on. I told you kita ada up and down motion tu at the peak. It's a V equals to 0. But is it relevant to this question? Let's see. It says throw upward at an angle from a certain height. So here, let's see the height. The height here is given as 0, 0. This is the coordinate that they specified. They have given this coordinate, bukan kita yang letak. Diorang letak kat sini, so 0, 0. Selalunya kalau ke atas, kita akan cakap it's from 100 ke, 120 ke, like the aeroplane example, right? But in this case, dia cakap kosong, which is fine. So bila kita start pada kosong, when we go down, we are actually, we will have a negative coordinate lah. In this case, they've given us x and then minus 45. So immediately we know that this building, including with the guy, is 45 something. Okay, it's 45 meter. Okay, it's 45 meters. So kat situ dia orang dah bagi the length of the building together with the guy, and they specified the coordinate kat bawah ni is a minus. So sebenarnya dia orang kasih hint dah. The hint is that the S is a negative. Okay, so the SY in this case is a minus 45. So how did they determine that? Sama je macam kita dah cakap sebelum ni, Y final minus Y initial. What is the Y final here? It's minus 45. What is the initial? It's a 0. So it applies, minus 45 still. This is your answer. Okay, kalau tak sure boleh buat. So your SY is minus 45 in this case. Your U, we already know this. Kita kena guna calculator sahaja. Apa lagi information yang kita ada? We know about the acceleration, right? Acceleration in the X is a 0. Acceleration in the Y is gravity, minus 9.81. We know this. And we also know that the final velocity in the X is always equal to UX. I think last class ada lagi yang tak faham about this one. So I hope boleh masuk dalam kepala yang Vx at all points, Vx sahaja akan sama dengan Ux. Benda ni is information yang kena ingat sendiri. No one will tell you this. So Vx at all points will be equal to Ux, and V equals to 0 at the maximum height is the information that you need to remember yourself. Okay? Okay, so now it's asking find the distance x and time to reach the ground. So it's asking about the total duration, and the distance x ni sx lah, ataupun range r. Okay, and then it's asking about the velocity when touching the ground. So it's asking the vector velocity in general. Maksudnya it's not asking about the vx or the vy, it's asking about the v. So v with theta is what they are asking. Okay, so let's do this quickly. I think at this point dah jadi senang kot. Senang. Okay, hopefully dah jadi senang lah. Okay, so Vy is V equals to Uy plus minus GT. And we already know that our Uy is some value. Okay, ada lori pula. Tak tahu lah korang hari ni. Tak tahu lori apa. Lori sampah ke? 10. Di sini 10. Okay, 10. So the UI is positive. Dia naik atas kan? Positif. Sini positif. So therefore Vy is equal to 10 minus 9.81 T. Kita tak tahu T apa. Do we know Vy? We don't know what Vy is. Do we know T? We don't know yet. We have the H. So what is the next step? What should I do here? Anyone? What should we do with this information? U squared plus 2as. Boleh. Can we use that? V squared U squared plus 2as.
Boleh.
Yes.
V squared U squared plus 2as. Okay, let's use that. And from here, kita tahu yang ni, and we already know this. So this would solve for the V, okay? So this is 10 squared minus 9.81 minus 45. Our S is minus 45 in the Y. 9.81 ni minus, ini plus sebenarnya. So minus akan dapat plus. So 100 plus 2 times 9.81 times with 45. Okay, 982.9. Betul ke saya kira ni? 100 plus 2 point. Betul ke? Okay, so this will give me V. Oh sorry, saya lupa nak square root. Square root answer. So V is
31. No.
31.35. Okay,
Yes.
thank you. So V is, mana nak tulis? Tak tempat. Okay, so V is 31.35. What should be the sign here? Positive, negative? Come on guys, Vy.
Negative.
Negative, right? Because it's going down. So our Vy vector mesti ke bawah lah. So it's a minus, okay? After you solve an equation, if it has a square root, always ask yourself, is it a positive or a negative? Look at it, okay? So V minus 31.35 meter per second, and put this into our equation. We can solve for T. Our T will be minus 31.35 minus 31.35 minus 10 divided by minus 9.81. So this will solve for my T. I will get my T as 4.22. If you get a negative T, maksudnya salah, buat balik. Okay, tu je jawapannya. 4.22 seconds. So we got the time to reach the ground. We got V at Vy. Now we want to find out what is the distance X. So kita akan buang kat sini. Kita nak cari distance X. So to find distance X, we already have T. The T for the X is 4.22 seconds juga. Kita dapat T untuk Y kan? Kita dapat T untuk vertical component, but the time for the horizontal component is exactly the same. Remember, time is a scalar. If you get time in the y-axis, basically you've solved for time in the x-axis as well. So kalau kita solve untuk time dekat sini, this is also the time for the x-axis. Kalau solve dekat time kat sini, this is also the time for the x-axis as well. So jangan ingat it's a component. Time ada komponen, time tak ada komponen. So it's basically the same. So 4.22 second, kita dapat kat sini. We already know what is the V, we already know what is the U and the A. We want to know what is the S in this case. So SX, let's see, UT plus 1/2 AT squared. I like this equation because this guy becomes a 0. And we already know what is the U. So that is a 20 cosine 30. It's a 17.32. This is also a positive because it's going to the right. So 17.32 over here. The time, we just use back what we got from the y-axis, 4.22 seconds. So that would give me 73.09. The unit is in meters because mole is in meter. Okay, so this becomes 73.09 meter. What else? We solve for the distance, we solve for the time, and then we want to know what is the velocity when touching the ground. Sama je, at this point dah patut senang dah lah. Vx squared, Vy squared, Vx is this value, Vy is minus 31.35 square root, sorry. V square root over here. So 20 cosine 30 is 17.32 squared. Mak tak suka tempat. So V is 17.32 squared, and then we have the minus 31.35 squared, square root that, then that is your V. Tolong kirakan kejap. And then for your theta, inverse tangent, Vy is minus 31.35 and your Vx is 17.32, and also this one. What is the theta? Dia akan dapat jawapan sama tak jawapan? Macam skema. What's the answer for V?
35.82.
35.82. Thank you. What about the theta? Did anyone try? Mana kita buat exercise?
Negative 61.08.
Thank you. 61.08 degrees. So negative, immediately that you know it's supposed to be below the x-axis, which makes sense because this is our vector and it is indeed below the x-axis. Okay, so let's see jawapan dia betul ke tak ada jawapan ni. Sekejap. Oh, tak ada jawapan, sorry. So I'm supposed to make the jawapan, but I think this is correct. Okay, so now we go for our first exercise. I want everyone to try this one.
Betul.
Yes, ada soalan ke?
Yang tadi tu, so time to reach the ground tu 4.22 second.
Yes.
Oh, okay. Thank you, Doctor.
Alright. Dia nampak macam senang kan sebab kita tak payah cerita pasal maximum height. Kita terus cari yang time untuk sampai hujung. So that is why nampak macam pendek daripada biasa kan. Okay. So I hope no one is confused. Oh, there's one more. Sorry. There's one more before we start with our exercise. Okay, so this one, it is thrown downward at an angle from a certain height. So dia turun macam ni. Alamak. Dia turun ke bawah lah. So if we wanted to solve for the ux and the uy, how would I do this? So this is my ux and this is my uy. So what should be the equation for my ux? Is it a sine or a cosine? Is it cosine? Okay, so it is 20 cosine 30. Is this correct? Betul ke?
Negative
Yeah.
30.
It should be negative.
Correct.
This is correct. Okay. Yang negatif tu kat sini ke? Ke tak perlu ada negatif? Negatif ke tak?
Our X tak perlu.
Kalau X tak perlu, betul. Yeah, our X is to the right. There's no negative. Okay, that is correct. Okay, what about our UI? What should we do with our UI?
Negative
20. Negative 20 sine 30 because
ke bawah.
sebab dia ke bawah, betul. Okay, so in this case, kalau kita letak 20 sine 30 sahaja akan dapat jawapan positif. Akan dapat jawapan positif. So kalau tak nak letak, kalau kita terlupalah, kita tengok it's below the x-axis. So sebenarnya you can write it 20 sine minus 30, then you will get the minus value here. But if you don't like that, you can just use 20 sine 30 and add on the negative sign later on. This is why it's very important for you to draw your x and y vectors to know that whether they are positive or negative. Tadi punya example, our uy was going up. So we looked at this diagram and we know, okay, so our uy is positive. And in this diagram, our uy is going down. Okay, I know that it is negative. So my answer, walaupun dapat positive, my answer should be a negative. You add in the negative value yourself, negative sign. Okay? So this is very, very important because it will affect the entire calculation. So please make sure your ux, uy is correct. Okay, so in this case, our ax is 0 or ay is minus 9.81. Dah jadi basi dah at this point. Harap semua dah ingat dah lah. Initial velocity is ux 20 cosine 30. Uy is negative going down. Final velocity Vx is always equals to Ux, so sama je. Our Vy we don't know yet. Our height is minus 45. It's basically the same example, except now dia malas nak baling ke atas, dia baling ke bawah. So dia kurang guna force. So sama je macam tadi. V squared equals to U squared plus 2AS. Kita solve for V. V squared U squared plus 2AS. In this case, we don't know what the U is. Sorry, we don't know what the V is, but we know the U. It is minus 10. And this guy is 17.32. So this is minus 10 squared plus, it's basically the same thing except that your values is slightly different. Minus 9.81, our S is minus 45. So you solve for V, what is V? And then from the V, V equals to U plus AT. Masukkan value V dalam ni, masukkan value U, and then you solve for time. Okay? And then using the time that you got from the vertical component, it should be the same time for the horizontal. And then carilah untuk S. So Sx is equal to ut. The A is 0, so it's just cancelled out. And U is 17.32, and then you use the time that you got from here. Then you get the distance x. So sama je, V pun sama, V equals to Vx squared plus Vy squared square root. Theta pun sama. Theta is inverse tangent Vy over Vx. Okay, perbezaan kat sini is just that this was very important for you to know that the Uy was going down. The negative sign was not given to you. You had to know it. You had to determine whether it's minus 30 degrees, boleh pakai macam tu, ataupun letak dekat depan dia. 20 sine 30. You didn't put the negative inside the bracket. Okay, so you had to put in the negative outside. Either way it works, asalkan tahu negative. Okay, it doesn't matter how you do it. Okay, so I think we're okay. So let's do this example. Kita dah cover symmetrical projectile motion, so I hope we can apply it in this example. So an artillery rocket, I want you guys to try this one, okay? An artillery rocket is fired, basically macam kereta kebal, is fired with an initial velocity of 300 meter per second. So V0 is equal to 300 meter per second at 55 degrees above the horizontal. So the theta of this V0 is 55 degrees positive. It explodes on a mountainside up 42 seconds after firing. So the time taken to reach the mountainside, that is your landing point. Apa yang kita tengah buat ni? Kita tengah shoot something, a bullet maybe. I don't know what we're shooting. Let's just call it a bullet. We're shooting a bullet using the rocket. I don't know if that makes sense. But the total duration to land is 42 seconds. Okay, it takes 42 seconds to reach the mountainside after firing. So now it's asking determine both horizontal and vertical displacement. It's asking Sx and Sy where it explodes. Maksudnya landing point. So this immediately becomes range. The Sx is range. Is this the H or not? Is this considered the H or not? Is it?
Yes.
It is. So kalau kita tembak kat sini lah. Macam tu ke? Kita nak buat projectile motion. So kalau dia maximum height, dia kena berhenti dekat sini. Is that correct? Sekejap, saya balik. Faham kan maximum height tu? Okay, kita ada projectile motion. So if you're saying that the displacement is the maximum height, the only way that we can achieve the maximum height is this at this point. Maksudnya, dia akan jatuh dekat sini lah. Dia akan jatuh kat situ. So is that correct? Is this given in the question?
No.
Wasn't given in the question, right? So we can't assume that, okay? So that's good. Everyone is trying to understand the question. So it's not the maximum height. It didn't say that it's the maximum height. So we cannot assume. However, the SX final position, the final position of X displacement is always the range, always. Tapi maximum height tak semestinya. Okay, kalau X, the displacement at the total duration is always the range, but not necessarily the maximum height. Okay, so this is correct, but this one is just SY. Okay, determine the relative to its firing point. So we can say that this guy is 0, 0. The coordinate is 0, 0. Sebab kita cakap relative to its firing point, which means that this is our reference point. Okay, you can put it as something else, but yang paling senang 0, 0 lah. What is its velocity when it hits the mountainside? It's asking for V, which means that you have to know what is the Vx and also the Vy. Okay, so if I were to draw this, kita kebal, right? So this is a terrible attempt. So let's draw the mountainside first lah. Okay, so this is our mountainside. We know our mountain should be tinggi, right? And let's say this is our ground. Okay, and kita kebal. Okay, korang terima je lah. At this point, I think you know that my drawing skills is below subpar. Okay, so it's firing something. So this is supposed to be a projectile motion. Sekejap, let me try again. Okay, macam tu contoh. Dia fire the rocket, dia fire the whatever that is firing. Maximum height dia tak semestinya dekat hujung. So okay, whatever it is. This is our landing point. The time taken to reach this point is 42 seconds. And we don't know what the velocity is. We know what is our initial V0. Kita dah tahu V0 is 300. And the angle is 55 degrees with respect to the x-axis. Okay, what else are we missing? 55, 300, 42. Okay, so I think that's it. So please try. I'm gonna give you guys around 7 minutes. So 10:57, let's talk about it. I'm gonna call out random names to help me. Make a table, X and Y, macam biasalah, okay? If you don't want to make the table, it's fine. But I think it's easier if you have the table. You separate between the X and the Y. Okay, 7 minutes from now, I'm gonna call out people. Kalau ada soalan, boleh tanya. Ni mountain tau. Okay, mountain, gunung. Wow, colouring pun buruk. Okay, nasib lah. What a check. Okay, bye Noel, Shaira.
Okay, thank you doktor.
Okay, no worries, don't rush, just ambil je vaksin tu, tak apa.
Okay.
So this one. For those yang kena ambil vaksin nanti, just tick in the attendance that you're going for a vaccination. Just let me know and then tick your attendance like that. Cakap you are excused. Okay, only for vaccinations. Vaccination, alamak, kenapa ni? Penting tahu ambil vaccination tu. Do not skip your vaccination for classes. Please utamakan kesihatan daripada kelas. Okay. The vaccination is your chance of survival. So that is beyond important than anything else. So please go take it. Don't skip the vaccination for class. Okay, so this is our X and this is our Y. Okay, can we get UX, X, Y, time, S, so now Adli to do UX. Okay, Isman hari tu hilang. So nak cari Isman hari ni. Isman do VY. Hasrin find the time. Kalau rasa macam nama korang selalu kena panggil, bagi tahu saya. Saya akan cari orang lain. Sebab kadang-kadang saya lupa. Kalau rasalah. Okay. Sebelah lagi. Fatihah dah pernah panggil. Fatihah dah jadi example. Hazira dah pernah panggil ke belum? Saya tak ingat lah. Hazira. Hazira SY. Okay. Kalau ada bantahan bagi tahu kalau rasa macam selalu kena panggil dah. And Iqbal Umran SX Iqbal. And then for the time is Mai Syahira. Okay, VX ni kacang je. So saya kasih siapa? Haida. Okay. So get ready. Oh, UI belum. UI Raihana. Okay. Is anyone balik hostel? Bukan balik. Is anyone applying to stay in hostel? Ada tak? Ke semua tak nak pergi hostel? Hostel pula, college. Tak Tak ada eh?
Tak ada.
Oh, dah lebih masa. Okay, are you guys ready? Adeli dengan Reihana, are you guys done?
Dah.
Okay.
Yes.
Okay, Adeli, give me the UX.
UX is 300 cos 55.
300 cosine 55. Value dia berapa?
Value dia 172.07.
Okay, is it a positive or a negative?
Positive.
Positive. Okay, thank you Adeli. Okay, Rai.
Alright.
UI is 300 sine 55.
Okay.
Value dia 245.75.
Is it a negative or a positive?
Positive.
Positive. Okay, thank you Rai. Okay, dua-dua betul So positif dua-dua ni kalau kita tengok, this is our V vector, our initial velocity. So this is the direction of the UX and this is the direction of the UY. So dua-dua patut positif. Okay, if you're not sure, draw it. Okay, Haida, what is the VX here?
Vx equal to ux.
VX equals to UX. Okay, thank you. 0, 7. Let me get rid of this. Okay, Isman, ada tak hari ni?
Ada juga.
Okay, so what is your VY?
Vy sama dengan 245.75.
245. Okay.
Tolak 9.81 darab dengan 42.
Darab dengan 42. Okay, so jawapannya?
Negatif 166.27.
0.27. Okay, thank you Isman. So Isman pakai V equals to U plus 80 dalam equation ni. Dia pakai time equals to 42 seconds sebab dia nak cari velocity kat hujung ni. Dekat hujung when it's landing, right? So dia kena pakai 42 seconds and the U ni masuk U macam biasa je lah. So jawapan dia V equals to minus 166.27. Thank you so much Isman. And then what is the time Hasrin? What should I put in the time here?
42 second.
Okay, thank you. What about what is the time for the X?
42 second also.
Okay, saja je nak test. Thank you so much. So jawapannya memang 42 second tak ada time lain. So it's just the 42 second which is the total duration to reach your landing point, and for Y and X it's equal. Tak ada perbezaan kat sini. Okay, so Hazira, can you tell me how to find SY?
Using V square equals to U square plus 2AS.
Okay.
Terus bagi tahu answer ke doktor?
Bagi saya
nak
plug in
nombor-nombor
values
dia.
dulu. Nak nombor-nombor dulu.
Negative 166.27 square equals to bracket 300 sine 55 square
Okay.
plus 2 bracket negative 9.81 S. So, SY equals to 1668.97 meter.
Is it a positive or a negative?
Positive.
Positif Yakin?
Yakin. Good.
Okay. Positif kita. Nanti kita go back to this. Okay, thank you so much Hazira, and then Iqbal pula. Macam mana nak cari
Sx is equal to 172.07 multiply by 42.
Okay. Jawapan dia
7,226.94.
700 7,000.
226.94
Okay. 0.94. Okay.
meters.
Thank you so much. Sorry tadi saya punya otak beli sekejap. Okay, 7,226.94. Okay, thank you. Does this answer make sense? Nampak macam okay tak? Ke macam besar sangat ke? Macam mana? Does it make sense?
Kilometer.
Kilometer. Did they tell you it's kilometer? Okay, so when kita pakai equation ni, kita akan dapat dalam SI unit, which is always meter. But if you want to convert to kilometer afterwards, boleh. Tapi sebenarnya when we use the equation, we always get in meters. Sebab kita use everything in SI. For example, time is in seconds. And then yang ni pun in meter per second. Okay, so when you solve it, you get the answer in meter. Tapi kalau nak convert jadi kilometer, boleh. So my question is, does the value make sense? Make sense tak? Is the SX displacement positive or should it be a negative? The displacement in the X. Should it be a positive or a negative?
Positive.
Positive. Okay. Our reference point is here. If we're going to the right, assuming we are, then it's a positive displacement lah. Unless it tells you it's going to the left. But dia tak ada kan? So kita always assume it's going to the right. Therefore, our displacement in the X is always positive. And for the Y, it's positive sebab kita atas gunung. Kita jatuh atas gunung. Kalau kita tembak, and dia jatuh ke bawah sini, I don't know how is that possible unless kita punya kereta kebal ni atas bangunan, which doesn't make sense, right? So gunung atas, dekat atas lah, so our displacement should be positive in relation to our reference point. Dia akan ke atas. So this is our SY and this is our SX. With respect to the reference point. So dia dekat atas. So SY positive, SX pun positive. Okay, so I think it's correct. I think everyone did a good job. So tak ada confusion kat sini. Semua orang tahu time sama untuk X and Y. And you guys know how to find the signs untuk UX, UI. And then displacement pun tahu. So now the final question is the velocity. So what is its velocity when it hits the mountainside? Ni saya buat lah. So V is equal to Vx, which is 172.07. It's a positive squared. And then your Vy is minus 166.27 squared. And whatever the answer is. Okay, so looking back at this diagram, what are we expecting in terms of the velocity? Should the angle be negative or a positive? What are we expecting here?
Angle negative.
Angle negative. Ada tak orang yang expect angle dia positif? Boleh tak jadi positif? Boleh ke tak boleh? Okay, my answer is sebenarnya boleh because I don't know bila dia jatuh, at what point dia jatuh. So let's say kalau projectile motion saya ni berhenti dekat sini and mountainside tu dekat sini, dia stop kat sini kan. So I don't know the angle tu whether it's below the x-axis or above the x-axis. We really don't know at this point. And the only way to know is to find out the angle lah. Okay, untuk tengok from our expectation, this is our own drawing. So I can't really say it's accurate because we don't have enough information. So sebenarnya the angle can be below the x-axis or it can be above the x-axis. We don't know yet. Okay, we have to solve for the angle. Okay, again, if my projectile motion looks like this, let me besarkan ni. Kalau gambar dia memang macam ni, then our velocity vector is like this, right? And our v x is this way and our vy is this way, so the angle is over here, therefore it is below the x-axis. However, if my projectile motion, dia punya mountain side tu dekat sini, kita tak tahu kan bila dia berhenti kan, at what point in this projectile motion did it land the mountain side. It can be over here, it can be here, it can be this way. So let's say if it's over here, then my velocity vector will be above the x-axis, and this would be my vx and vy. Okay, I hope everyone understands this point. Yang ni adalah gambar saya lukis sahaja. I really don't know if it's correct or not. So the only way to know is to solve it. Okay, so let's see. Kita punya vy is negative and our vx is positive. So if kalau nak lukis roughly lah, vy negative macam ni, vx is this way, therefore our velocity vector should be this way and it is below the x-axis. You can determine from the vy and the vx. Okay, so now kita solve je lah macam biasa. Inverse tangent theta is equal to inverse tangent of vy minus 166.27 over s 172.07. Okay, so ada tak orang boleh kasih saya jawapan macam biasa? What's the angle and what's the magnitude here? Saya pun kira sekali. 72.07.
Magnitude 239.28.
39.28, thank you. What about the angle?
Angle 44.0.
44.01.
Is
02.
it negative or positive?
Negative.
Negative.
Okay, so we got a negative angle, which is what we are expecting from our Vx and Vy here. Okay, it's a negative. So minus 44. Maksudnya gambar saya lukis ni betul lah. Walaupun saya agak-agak je, but it turned out correct. So kalau kita nak lukis betul-betul, okay, so this is our projectile motion and this is our mountain. Jadi kecil sikit sebab saya nak lukis. So this is our V, this is our Vx and this is our Vy. Okay, and this is our angle of 44.01. It's below the x-axis, it's a negative. Okay, that is how it looks like. Any questions about this problem? Is everyone okay?
Doktor.
Yep.
Doktor boleh explain kenapa kita ambil total time 42 second?
Kenapa kita ambil 42? Okay, boleh? Thank you for the question. Okay, so in the question it says that an artillery rocket is fired after an initial velocity above the horizontal. It explodes. It explodes on the mountain side 42 seconds after firing. Dia meletup, maksudnya motion tu berhenti dekat situ. Okay, bila kita tembak bom lah kita tembak bom, lepas tu dia meletup kat sini atas mountain side, motion dia habis kat situ, which means that is the total duration of our projectile motion. This is why I use the 42 second as my total duration. In your opinion, I mean, what was your confusion about? Kenapa tak rasa 42 second tu total duration? What did you think it was? Is it the maximum height?
Tak ingatkan perlu cari time yang lain sebab kan total time tu komponen X macam tu.
Okay, sebenarnya tak ni dia kasih total duration. Okay, so last time pun my other student pun ada this confusion. So kenapa pakai 42 second as a total duration? Sebab projectile motion tu habis dekat 42 seconds. So you don't have to find another time lah. Basically this is the total time. Okay, if you're wondering how to find the total time, it is when the projectile motion ends. When does it end? It explodes. So habis lah. Okay, so it's 42 seconds. Okay, thank you for the question. It's a good one. Banyak orang confused kat situ juga sebenarnya. Any other questions? Is everyone okay? Tak ada confused dah? Okay. Alright. Moving on to our, let me see. Do we have an answer? Okay, we do have an answer here. 43.98 below the x-axis. Macam slightly different I think. 44. Yang ni dapat 43.98. Okay, lebih kurang lah. Lebih kurang tak apa. What about the vertical displacement and the horizontal? We have here 7,230. 7,230. Boleh lebih kurang, dapat lebih kurang. And the XSY displacement is 1.67 times 10 to the 3. 1.67 times 10 to the 3. Okay, betul. Ini pun betul, lebih kurang. Velocity when it hits the mountainside, we get the same answer. 239. Betul. 239? 239, betul. Yang ni kita kalau kita besarkan, kalau kita expand the scientific notation, we get rid of it, it's 239 meter per second. Okay, you can represent your answer in scientific notation or in kilometer, boleh. Asalkan jawapan dia betul. Jangan pakai scientific notation lepas tu salah. What else? I think we got the rest correct. So that's good. Okay, good job everyone. Okay, another example that we should do to test our understanding. A man stands at the edge of a cliff. At the edge of a cliff. Macam mountain yang sama, but it's not. It's a different one. Okay, ni orang. Dia stand kat hujung ni macam nak jatuh tapi kaki dia masih cecah. And throws a stone horizontally. Throws a stone horizontally. Very important keyword here. Dia baling. Horizontally. Maksud kat sini dia baling sebiji batu Okay, dia baling sebiji. Sebiji batu. With a velocity of ux sahaja. Okay, kita tak patut cakap ux lagi at this point. We just say is v0 with a speed of 18 meter per second. But the keyword horizontally means here that ux is 18 meter per second, uy is equal to 0. This is what it means. The cliff is 50 meter above the ground. Kita anggap sekali dengan orang ni lah. So 50 meter above the ground. This is 50 meter above the ground. Which means to say if we want to say our ground is 0, 0, we can say that this guy is 50, 0, 50. Okay, this is our x-axis and this is our y. Our x is at the reference point of 0. I shouldn't put it here. It should be at the place yang orang ni baling batu sebenarnya. Let me redo this. Takut korang confused. Okay. So saya kena buat dekat orang ni kat sini. Susah nak lukis. Sabar sekejap. Nanti saya lukis nanti korang confused pula. Bahaya. Okay, so this is where I'm at. No, this is not me. This is someone else. 50 meter. If we say this is our reference point, this would be our 0 in the x and 0 in the y. Okay, ground. And tempat dia baling ni would be 0 in the x and 50 meter above the ground. Kita baling stone, 50 meter, 18 meter per second. Angle dia kosong because it is projected horizontally. Macam mana saya tahu angle dia kosong? This is our x-axis. Dia baling macam ni. What is the angle with respect to the x-axis? It's 0. Tak ada angle. Okay. So ux is 18. Macam mana saya tahu 18? Kalau saya nak kira pun, it's a 0, right? The angle is 0. Ux is 18 cosine 0. Cosine 0 is a 1. So you get 18. What about uy? Uy is 18 sine 0. This guy is a 0. So you get a 0. Okay. So projected horizontally, it's a 18 in the ux. How long after being released? Lepas dibaling tu, how long after being thrown? Patutnya thrown, the word is thrown. Does the stone strike the ground below the cliff? So dia tanya, bila kita baling ni, bila dia jatuh? So So this is asking for the T. With what speed and angle of impact does it land? So it's asking V and theta. Okay, so let's do this. I'm going to give you guys another 7 minutes. Kita akan discuss macam biasa. 11:25. Let's talk back at 11:25. Saya akan panggil orang lain pula this time. Okay, siapa yang belum kena panggil tu, get ready, okay? Okay, get rid of this and make a table. Excuse me. Doctor, okay, ada soalan doctor is asking for speed. Does it mean that there will be no sign for velocity? As speed is a scalar. Betul, speed is a scalar, but it's asking what is the speed and the angle. So basically we are still finding the velocity punya magnitude and also the angle, because velocity without its positive or negative is speed. So basically kan cari velocity jugalah. Okay, and ditanya pasal angle. Okay, that's a good question. Sebab kita baru belajar kan pasal speed and velocity. So Aliman said it's asking for speed. So do we need to find velocity? The answer is yes, because it still is asking about the angle. Velocity, when we make it into magnitude, it is basically speed. Okay, so cari velocity je lah macam biasa. So this is X and this is Y, UX. Okay, nak assign siapa this time? Can I get Nurin over here and Rashida or Shida, and then Najla. Faris. Saya rasa macam pernah sebut nama Faris tapi tak ingat. Aliman Zafran lah. Zafran, SY. Aina Sakina, VY. Oh, I think some of you dah siap lab 2. Ke bukan kelas korang? Oh yeah, Aina yang request kat saya. So that's good. Harap orang lain boleh follow through walaupun kita tak specify deadline lagi. So Alisa Nazir, yes. Alisa saya rasa saya tak pernah panggil rasanya. And Daphne for time. After this exam. This is our last example. Lepas ni kita akan masuk graph. So habis. Hopefully. So please try to do this yourself and see if you really understand how to do these problems. Nanti kena buat assignment kan. And then akan ada exam. Itu je lah point dia sebenarnya. And you can also use these concepts for your mini project. Boleh. Okay, you can talk about basketball, talk about bullets, whatever. um, 11:25. Okay, another 2 minutes. Okay, dah terlebih masa. Nurin dengan Alisa, are you guys ready? Okay, Nurin, what is the UX here?
18 cos 0
18 cosine 0. That's the
equals
18. Okay, is it a positive or a negative?
positive.
Positive, okay. Alisa, what's the UI? Alisa?
18 sine 0.
80 sine 0. 18 sine 0.
18 sine 0.
Alright, so you get 0, right? Does it matter if it's a positive or a negative? Alisa?
Yes.
Okay, so is it a positive or a negative?
So positive.
Positif Okay. Kalau ke kosong dia tak ada sign Positif atau negatif tak ada. Okay, that was a trick question. Okay, so Alisa and everyone else, kalau kita punya jawapan kosong, there's no positive or negative associated. There's basically nothing happening. Okay, so thank you for that. Thank you for answering. And then Rashida, salah tak apa Don't be embarrassed in this class. I think everyone at one point akan buat salah juga. Okay, VX, Shida?
Vx equal to ux.
Okay.
18.
Okay. Aina Sakina? BY? Aina Sakina? Okay, ada check tak ada. Okay, Aina is missing. Aina? Okay, Aina tak ada. Okay, Najla, what about the time for the X? How did you do it?
Saya dapat jalan kira je tapi saya tak dapat jawapan.
Okay, what's the jalan kira?
V squared equals to U squared plus 2AS.
Okay.
So U squared is 18
Okay.
plus 2
Plus
0.
0.
50. That's equal to 50.
Okay, so 50 ni, is it referring to the X or the Y? Is it SX or SY?
Oh,
Apa?
it's X. Y.
It's Y. Okay, so the 0 ni, yang ni Y. Okay, ni Y. Yang ni 0 ni?
X equal to 0 kan?
So equation ni betul ke salah?
Salah.
Salah, okay. I'm gonna give you a few more minutes nanti awak buat balik So Najla, pending. Buat balik Alright, Faris, SX.
Saya buat S equal to UT.
Okay, S equals
Dapat 57.42.
dapat 57.42. What is your U here?
U, mana jam? 18.
Okay, 18. And the time that you used here?
Time, 3.19.
3.19. Okay, so jawapan akhir tadi berapa? Sorry, saya tak dengar.
57.42.
57.42 meter. Okay, nanti kita tengok betul ke salah. Thank you, Faris.
Okay.
And then Daphne dululah. Kita tengok Daphne buat time macam mana. Sorry, VY tadi siapa? Aina. Aina tak ada. Okay. Daphne dulu. T. Sini Aina. Okay. Daphne, macam mana cari time?
Vy equals to Uy plus Ayt.
Plus Ayt. Okay. So this would give you 0, right?
Negative 31.32 equals to negative 9.81 T.
Sekejap negative 31.82. 82
31.32.
0.32. Okay. 0.32
equals to negative 9.81 T.
Okay, so akan dapat TS
3.19.
3.19. Okay, so dapat sama. 3.19. So definitely pakai V equals to U plus 80 and substitute V for minus 31.32 and the U is 0 and then minus 9.81 which is the AY and then find out T. Saya nak tulis balik. Okay, thank you Daphne. Minus 31.32. Minus 31.32. Sorry. So kita akan tengok jawapan orang lain macam mana. Minus 31.32 equals to 0 minus 9.81 T. So this was how Daphne found out T. Okay, and then SY. What is the SY, Zafran?
The SY is negative 50 meter.
Okay. Kita ada issue kat sini. It's straightforward because it's in the question. Okay, thank you Zafran. Aina, Sakina, are you there?
Yes, doctor. Sorry, doctor.
Apa dah apa. Alright, so how did you find PY?
So, 0 square plus 2 multiplied by negative 9.81 and multiplied by negative 50.
0 squared, lagi sekali sorry.
0 squared plus
plus
2 multiplied by negative 9.81 and multiplied by negative 50.
Akan dapat V squared, right? So the
Yes, and the answer is negative 991.
991.
81
points?
No point.
Okay, that's this one. Thank you. So immediately Aina cakap, okay, the V is a negative. And I appreciate that sebab selalunya saya kena tanya. So kita punya ni ke bawah kan? So our Vx should be positive, our Vy should be negative. So Vy is negative lah. Okay, in this case, this is the Vy. Okay, Najla dah dapat tak? Macam mana cara?
Zero
Time awak zero. Macam mana awak kira?
V equals to U plus 80.
Okay.
18 equals to 18 plus 0t.
Okay. Kalau 0 times t dapat berapa?
0.
Dapat 0. So 18 equals to 18. Macam mana? Salah equation juga kot. Okay, tak apa Najla. Thank you so much for trying. Dah 2 kali awak try kan? Tak apa, kita try discuss Okay, so macam mana kita nak cari macam mana kita nak cari time using the x values yang kita ada. Kalau kita nak cari using x lah. So kita ada 18u, kita ada 18v, kita ada a equals to 0. And then kita, what else? Kita ada u, y, kita ada, if I'm just going to use the x values, sebenarnya I cannot solve it using x. But I can solve it using the y values. And can I use the y values? I can actually. Because it's the same, right? Time is same for x and y. So sebenarnya Najla boleh pakai equation untuk y to solve for t in the x. Because it doesn't matter. For time, it doesn't matter which one you use. If you're using x, semua kena pakai x. Kalau if you're using y, semua kena pakai y. Tapi value time tu referring to both x and y. Sekejap, saya ada chat. Ada soalan kot. Doktor, Vy tu tak square root. Vy tu tak square root. Oh, is it? Is it not? So 981
Ya, lupa. Sorry, doktor.
Okay, so kalau kita square root dapat berapa?
31.32.
1.32. Okay, so negative kan? 31.32. Thank you. Hasrin, dia notify kita. So untuk Najla and everyone else yang confused about time in this case, Daphne dah solve for time in the y. Kita boleh terus pakai time yang sama, which is 3.19 seconds. Kita boleh pakai time yang sama. So does it mean that I have to solve the time in terms of x values? Tak semestinya. Walaupun saya letak time dalam x punya column, I can actually solve for time in the y. Boleh. You get the same answer. Okay. Kalau kita nak solve using x values, tak boleh sebab kita ada u which is 18 and then kita ada v which is 18 and Najla got into a dead end sebab itu saja value yang dia ada. And whereas Daphne, dia ada u, dia ada boleh cari for, dia ada s, so she could find for the time here. Okay, so basically I set Najla for a dead end lah. Okay, sorry Najla. But it was necessary for us to find this dead end so that I can tell you that time you can solve using y values. So I hope that clears any confusion. Kalau tak boleh solve pakai x values, time boleh pakai y values. Tapi kena pakai sama. Kalau pakai y, semua kena y. Kalau pakai x, semua kena x. Macam tadi Najla dia campur x dengan y dalam satu equation. That is wrong. Walaupun nak cari time ni boleh untuk x dengan y, tapi kena consistently pakai y ataupun consistently pakai x in your equation. Okay. So we got time, we got v, we got our s. So what is the speed and angle of impact? Does it land? So v sama je lah. Okay, we already have our vx and vy. So it's 18 squared plus minus 31.32 squared and square root the whole thing. And can someone find out what is v? And for the theta is inverse tangent. Vy is minus 31.32 and Vx is 18. And immediately we know that this Vx is positive and our Vy is negative, which means that our V angle should be below the x-axis or a negative angle, right? So what's the answer here? Anyone?
36.12.
26.12 20
36.
36, okay. Meter. So this is the magnitude of your velocity or speed. Boleh. So this is also speed because it's magnitude. Magnitude maksudnya tak ada direction. Okay, what about the theta?
Negative 60.1.
Negative 60.1.
1.
1.
Alright. Okay, so this is our angle 60.1 ataupun kat sini 60.1. Okay, so I hope everyone is clear. So the trick here was tak ada trick sangat, tapi sebenarnya kita confuse dekat x tadi kan, x axis untuk time. Time refers to the same value for y and x. Okay. So the answer is 3.19, betul. And then speed is 36.1. Was that 36.1? And the angle is minus 60. 36.1 minus 60, which is below the x-axis. Okay, so that's great. We got the answer. Okay, yay. Kita dah habis example untuk projectile motions. Now we go into the graphs. Okay, kita ada masa lagi. This is our last subtopic and let's finish it and then we are done with chapter 2. So this is the next subtopic and the last one, which is dealing with graphs. So basically when we have motion, kita boleh plot it in terms of graph, and from the graph we can get the gradient. At this point kita dah tahu dah macam mana nak cari gradient from our first lab and also from our second lab. Sekejap, I have a question here. Doktor, kenapa yang VV kita guna negative 50? Kalau guna negative 50 kita dapat jawapan positif untuk VY. Kejap. Okay, ada orang ada soalan. Aizat is asking a question. Doktor, kenapa kita pakai VY as minus 50? Kita tak pakai VY as minus 50, kita pakai SY untuk S minus 50. Aizat boleh unmute tak and ask me your question directly? Mana yang minus 50 tu
Kan kat VY tu yang kita nak cari VY. Kan kita ada guna tu negatif 50 tu kan. Dia kalau kita darab negatif 9.81 dengan negatif 50, kita akan dapat positif, doktor.
Okay.
Itulah saya nak tanya sebab jawapan dia kan negatif 31.32.
Oh, okay. So the confusion is yang ni 2 darab minus 9.81 darab minus 50, jawapan dia positif. Kenapa VY negatif? Itu ke soalan awak?
Ya.
Okay. So because here kita pakai V squared kan. Bila kita ada V squared bermaksud kita kena square root this whole thing untuk dapatkan V. Okay, let me besarkan kejap. Let me just write it somewhere else lah. Okay, when we have V squared equals to 0 squared lepas tu plus 2 plus 2 minus 9.81 minus 50. Okay, so these two things become positive, betul? And then therefore we get some 981, I believe. We get 981, sorry 9.81 pula. 981 kot. Sekejap 2 times 9.81 times 50, you get 981. And this is V squared. Okay, like I mentioned to you before, I think some of you dah terlupa. When we square root something, memang akan ada positif negatif. When we square root something, memang akan ada positif negatif. So, bila kita nak tahu tentukan if it's a positive or a negative, we look at our question. We are going down. So our Vy should be a negative. Kita yang tentukan sendiri negatif tu. Jawapan dia akan dapat positif negatif 31.32 meter per second. Me as someone yang menjawab soalan ni, I should look at my diagram, I should look at my question, tentukan sendiri what is the direction of my Vy. In this case, we already know it's going down. So I will choose negative sign. Okay. If that still confuses you, kita akan go back to basics. 2, positif 2, square root dapat 4. Negatif 2, square root dapat 4. Square root of 4 can give me positive 2 or negative 2. So this is where the negative comes from. Anything that you square root, you will get a positive, negative. This is for vectors punya jawapan sahaja. Kalau kita cari V untuk magnitude ni kan, kita cari magnitude kat sini, yang ni sebenarnya ada this modulus sign. When I square root the 18 squared plus dalam kurungan minus 31.32 squared, walaupun jawapan dia positif negatif, I am only concerned about the magnitude because of this modulus sign. So this answer will always be positive. I don't care about the negative, I don't care about the positive sebenarnya, I just want the value. This is for the Pythagoras theorem equation. Specifically for the Pythagoras theorem equation untuk cari magnitude. And then direction akan dapat dari sini. Okay, but in this case, kita dealing with linear kinematic, kita dealing with vectors. Vy ada direction positif negatif. So saya pilih negative sign tu because it's going down. Does that answer your question, Isaac?
Yes, thank you Dr.
Okay, ingat yang ni kita when we have a square root positif negatif, pilih positif ke negatif jawapan tu. Okay. Okay, so let's move on to the next one, displacement time graph. So information from the graph, this is a displacement time graph. How do I know it's a displacement time graph? This is x in meter, displacement ataupun distance, tapi dalam case ni displacement, and this is the time. Kalau tengok kat sini, dia letak T dalam kurungan S. Kena ada unit. Kena ada unit, and sebenarnya nak lagi tepat time. Tulis penuh-penuh, displacement, meter. If they ask you to draw a graph in your exam, please write the full name. Jangan guna short form because sometimes we don't know if you understand what the short form means. Okay, and then we have a negative, negative 40, negative 20, 0, 20, what is this, 30 maybe, 40, 60, and then the time is always positive. Time tak ada negatif kan? And then displacement boleh jadi positif, negatif. So immediately we know that this is the displacement graph. It's not a distance. Kalau distance graph, semua positif. Kat sini kita ada negatif, positif, maksudnya displacement. Information that we can get from the graph. Okay, let's say what is the displacement at time 30? So this is time 30. What is the displacement? The displacement is 0. So Abu is at 0 with respect to the reference point. What is the displacement at time 40? So look at here and we look at the displacement. Okay, Anis is, it should be the same person. So Abu is at minus 35 with respect to the reference point. Hopefully this is minus 35, I don't know. Okay, so from this graph, I can tell what the displacement of the object is or the person is. What about the average velocity? Average velocity, what is the equation for average velocity? V is equal to, apa? What is it? Anyone? Ingat lagi tak? Ke dah lupa dah semua orang?
Delta X per delta T.
Per delta T. Okay, so the X refers to X final minus X initial over T final minus T initial. So when we are talking about average, kita selalu tengok where's the last point and where's the starting point. This is our last point. This is our starting point. What is the coordinate for our starting point? Coordinate is 0 in the X and 36 in the Y. I don't know. It looks like 36, I think. And what about the final coordinate? It is 50 in the X. Okay, I refer to the time as X, right? And Y coordinate is, let's say it's minus 50 lah. So with these coordinates, I can find out what is my average velocity. So X final is 50. Okay, ni final kan? Yang ni initial. Okay, final, initial. So final F, this is Fx, this is Fy, this is Ix, this is Iy. I should say S. Okay, tak apa. So 50 final in the X and then, the displacement is Y axis. That's why I was confused. The displacement is the Y axis, walaupun nama dia X. So this is referring to the Y axis values. This is referring to the X axis values. So saya pun confused tadi. So Y axis is this guy, this guy minus 50. This is your final displacement in the Y minus initial in the Y, so it's a 36. And the time in the X final is 50 minus 0. We started at time 0 over here. Okay, so minus 50 minus 36 is minus 86 over 50. So that is minus 86 divided by 50. It's 1.72 minus 1.72. And the unit should be meter per second. Macam mana saya tahu? This guy is in meter. Alamak, tak cukup tempat. This guy is in meter and this guy is in second. So the final answer is meter per second. Dia negatif, bermaksud velocity negatif lah. Okay. Dia ke belakang. Macam mana kita nak tahu dia ke belakang? Kalau tengok graf ni kan. Okay, saya padam dulu . Okay, I think the coordinate should be maintained there. Let me write it back. Oops. Coordinate tadi berapa kan? 50.
50-50.
Berapa?
50-50.
50-32? Bukan 36
50-50. 50-50.
50 negatif 50.
Betul. Sorry. 50 negatif 50. Thank you. And this guy was 0 minus 36. Okay, thank you guys. Okay, so average ni bila kita nak lukis garisan average velocity, it goes from here to here. Let me use a sign pula dah. Let me use this guy. Okay, sorry I'm taking my time pula dengan benda ni. Tapi it's important. Okay, when we try to find the average velocity, what am I trying to find? I'm trying to find the gradient of this point. Okay. Hello, kenapa dia tak boleh tekan pula? Okay, I'm trying to find the gradient of this point. This line extends from the initial to the final, and I want to find out what is the gradient for this line. That is the average velocity. The gradient for this line is average velocity. Okay, and as you can see, it's going down. When we have a gradient that is going down, it's a negative. So the average velocity in this case is a negative m. So it's a negative value. Okay. Saya ada soalan dalam chat. Sekejap ya. Macam kira gradient kan doktor? Ya betul. Betul right. It's like calculating for the gradient. So this equation is actually the gradient. This is x final minus x initial. Okay, let's say jauh sangat pula nak buat. So kalau kita nak kira gradient yang sebenar-benarnya kat sini lah kan. Tapi kalau saya kira gradient yang kecil ni pun, it will give me the same answer because it's a straight line. So gradient kecil versus gradient besar akan bagi saya jawapan yang sama. That is why when I find using the values over here, it's the same as finding the values over here. It will give me the same answer. This is for average velocity specifically. Okay, now we talk about instantaneous velocity pula. So you will get a negative gradient for the average velocity. And for the instantaneous velocity, let's talk about instantaneous. Instantaneous, I told you before, it is the velocity in a short duration of time. It's not the total duration, but a duration that is shorter than the total duration. So let's say I want to know, hey, what is the instantaneous velocity from B to C? So if I wanted to know the instantaneous velocity from B to C, I would connect it first from here to here. Let's use a different color lah untuk membezakan. Let's use, nak pilih color pun lama kan, kejap. sorry. Let's use blue. No, this is already blue. Green. Okay, so let's use green untuk instantaneous and blue untuk average. So this is our average. Tak berapa center tapi korang faham sendirilah. So green is our instantaneous. What is the instantaneous velocity between B to C? Between displacement B and C. So instantaneous velocity V instantaneous velocity V, it doesn't have this sign anymore, is CY final, C is final, BY over B over CX minus BX. Saya pun confused. Okay, so basically it's delta Y over delta X, or in this case it's delta X over delta time. This confuses me. This is the issue here. Okay, so basically it's the Y-axis, change in the Y-axis over the change in the X-axis, or the change in displacement over the change in time, but from point B to C sahaja, bukan daripada A to F. It's from B to C sahaja. This gives you the instantaneous velocity. Okay, in this case, let's just try one time. This is 20. This is 39 maybe. And for the B, it's 10. And this is 50 lah. Okay, so delta Y over delta X. So delta Y is 39 minus 50 over delta X is 20 minus 10. So this is your instantaneous velocity. 39 minus 50 divided by 10. So you get minus 1.1. So as you can see here, the average velocity versus the instantaneous velocity can be different. It doesn't have to be the same. Selalunya akan different lah. Okay, so this is instantaneous velocity from B to C. What about at other points? What if I asked you, what is the instantaneous velocity at this point? Specifically at B. Boleh. Walaupun dia tak daripada B to C, dia tak C to D ke apa, it is just at point B. So saya besarkan. How do I solve for this point B? Boleh. Sekejap. So does anyone want to guess what is the velocity at point B? Instantaneous velocity at point B?
0.
0. Yeah, betul. This is the gradient. How do we find the gradient? It's non-existent. M equals to 0. M equals to 0. The gradient of a displacement graph gives you velocity, and if the gradient at this point is 0, then the velocity is also 0. So V at point B is equal to 0 because the gradient is 0. So kalau kita nak kira using the graph lah, let's say macam tak puas hati kan, okay, m equals 0 tapi tak ada bukti pun, I have the proof here. So kita besarkan benda Allah ni. Kita besarkan dulu. So kita cari dekat specifically at these 2 points. Boleh kan? Boleh. It's still a time duration. So I don't know what time that is. Let's say it's from 9 to 12. From 9 seconds to 12 seconds. It is at point B. Lebih kurang lah. Kita anggap lebih kurang. And then the displacement at time 9 and time 12 is exactly the same, which is 57 maybe. So at time 9, the displacement is 57. At time 12 second, the displacement is also 57. So if I wanted to put in my equation, I can do that. So the change in the y-axis over the change in the x-axis, ataupun the change in displacement over the change in time, the change in the displacement is 57 minus 57. The time is 12 minus 9. I can do that. So this is 0. 12 minus 9 is 3. 0 over 3 is 0. So the gradient is 0. So that's your proof that the gradient is 0 and velocity, instantaneous velocity at that point is 0. Does this remind you of anything? This v equals to 0. Does it remind you of anything? What does it look like? V equals 0.
Maximum height.
Maximum height, yeah. If you look at here, where is the maximum displacement at this point, right? It has the up and down motion. It is the maximum displacement. That is your maximum height. Therefore, the gradient at this point is v equals to 0. So when we talk about projectile motion, we say that this point is v equals 0. We are referring to the gradient, or we are referring to the change in displacement over the change in time. And at that point, the change in displacement is so small that it is equal to 0, as we saw over here, right? So it all ties back together lah. If it doesn't make sense, try to make sense of it. Kalau tak make sense juga, maksudnya you are missing an info and you need to fahamkan lagi lah. Okay, so that is your V instantaneous velocity at point B. We can do the same for point C. We can do the same at point D. Sama je. So this is the gradient, this is the gradient, this is the gradient. How do I know how to find the instantaneous velocity? I make a small line. Kenapa line saya tak wujud pula ni? Sama je lah kita buat line macam B juga. What was the shape that I used? It's a straight line like this. Tapi patutnya colour dia orange. Patutnya colour dia green. This is not working well. Sekejap. Green. Okay. Doesn't really show up, but that is your line to find the gradient. Instantaneous velocity at D. Adjust. Make sure it's totally on D. So that is your instantaneous velocity. Find out the X and Y coordinates. Find the instantaneous velocity. Okay. So any questions about the displacement time graph? To find the displacement, to find the average velocity, and to find the instantaneous velocity. Semua orang faham tak? Confused ke ataupun faham? Kalau confused kat mana? Okay, let me repeat myself. Untuk displacement, kita terus cari directly from the graph. Let's say, what is the displacement at time 30? So terus tengok graph. At time 30, the displacement is 0. So that is how you use the displacement time graph to find out the displacement. Using the displacement time graph to find the average velocity, you have to find the final coordinate minus the initial coordinate. In this case, our final coordinate is F and the initial coordinate is A. The average velocity is your change in the y-axis over the change in the x-axis, tapi kena specifically pakai final tolak initial. Dalam case ni, final is F, initial is A. Kena pakai coordinate kat situ. Kalau tak nak pakai coordinate kat situ, make a straight line connecting both points and find the gradient of this line. Boleh juga. That is another approach. That is your average velocity. instantaneous velocity, how do you find it? You make a small line at that point that you are trying to find the instantaneous velocity. In this case, we can find the instantaneous velocity at point B, which is 0. We can find the instantaneous velocity at point C, which is a negative. The slope is going down. We can find the instantaneous velocity at point D. Just kena tahu cari gradient dia kat situ lah. Specifically at the small section only. Cari kat situ sahaja. Jangan cari for the entire graph. Cari dekat the small section sahaja. In this case for B, kita cari dekat time 9 to 12. Cari kat situ sahaja. Okay, tak ada soalan Kalau soalan boleh tanya macam biasa. Okay, so this is recap displacement obtained from the final position to the initial. Okay. Average velocity equals the slope of the line joining the initial and final. So in this case, it's A to F. Alamak. Okay, korang tahulah. Instantaneous velocity is the tangent slope at a specific point, B, C, D, E, F. Kat sini 0. This is V equals 0. V equals to 0. This is a V negative. This is a V negative. This is a V negative. Instantaneous, and then this is a V positive. So the instantaneous velocity can change. Whereas the average velocity, you will only have one value for average velocity. Instantaneous boleh macam-macam. Sebab dia small durations. And then what if we have a graph that looks like this? This is our displacement time graph juga. But now, our displacement is a straight line. Either ke atas ataupun ke bawah. In this case, the displacement is increasing. And in this case, the displacement is decreasing. So this is the change in X is negative. The change in X is positive. The slope of the line is the value of the average velocity. So kat sini kan dia punya displacement is just a straight line. So therefore, whatever gradient that you get at any point will give you the average velocity. Sebab sama je kat semua tempat. Kalau kita nak buat from A to D, if I connect this point together, A to D, I will get the same line lah. And finding the gradient at this point is equal to the finding the gradient at this point and is equal to the gradient at this point. So the average velocity is equal to the instantaneous velocity for a uniform velocity. For a linear motion lah basically. Ni linear motion dia bergerak sehala. Dia gerak positif je, tak ada turun-turun. Yang ni bergerak negatif je, tak ada turun-turun, tak ada naik-naik. So kalau kita bayangkan Rafiq tengah jalan, dia jalan ke kanan je. So this is a linear motion and I told you kalau linear motion, average velocity sama dengan instantaneous velocity. Linear motion sahaja. Kalau kita tengok tadi, this is not linear. Mula-mula kita naik, lepas tu kita turun, lepas tu turun, lepas tu berhenti. So this is not linear sebab kalau kita bayangkan Rafiq tengah jalan, dia naik, this is positive displacement, lepas tu dia patah balik. So tak berapa linear lah kan, dia ada patah balik kan. So displacement dia berubah-ubah and velocity dia pun tak seragam sebab kadang-kadang dia laju, kadang-kadang dia lambat. Fatihah pun last time kejap-kejap nak jalan slow, kejap-kejap nak jalan laju. So yang tu tak uniform tak uniform velocity. So when we have uniform velocity such as this case, dia kena bergerak dalam kelajuan yang sama and dia tak ada patah-patah balik. Dia kena bergerak dalam kelajuan yang sama dan tak ada patah-patah balik, akan dapat graf macam ni. So this graph tells us velocity is uniform. What does uniform velocity mean? It means that kelajuan yang seragam lah. Tak ada laju, tak ada slow, sama je. Macam mana kita tahu? Kita tengok gradient dia. Gradient dia kat semua tempat sama. Maksudnya V1 equals to V2 equals to V3. Sama je at all points. Kat sini pun sama. Walaupun dia bergerak ke bawah, gradient dia sama. Kalau kat sini kita cakap V4, V5, V6, V7. So V4 equals to V5 equals to V6 equals to V7. Sama sebab gradient dia sama. Positive gradient means positive velocity, negative gradient means negative velocity. Okay. And then this one. This is a velocity time graph. Tadi kita cakap pasal displacement time graph. This is a velocity time graph. Sorry sikit lagi. Saya tahu semua orang macam dah macam dah lalu kan. Sikit lagi. Bear with me. So this is a velocity time graph. In the information that you can get from this graph is velocity. So at time ti, the velocity is vi. At time t final, the velocity is v final. This is direct information that you can get. You can also find the average acceleration. Average acceleration is the change in v over the change in, over the change in time. Okay, so this is your average acceleration, v final minus v initial, t final minus t initial. In this case, diorang specify yang ni adalah initial, ni adalah final. So coordinate dekat coordinate dekat Q tolak coordinate dekat P. This is final, this is initial. So that is your average. Kalau nak buat line pun boleh. Bear with me, jangan tertidur. Sikit lagi ni, kita nak habiskan. So this is the gradient of your average acceleration. Okay, what about your instantaneous acceleration? You can find it from this graph as well. I think at this point korang dah faham kot. Kalau kita cari dekat instantaneous, kita cari kat tempat-tempat yang kecil sahaja, small duration of time. Let's use green again. Besarkan sikit sebab tak nampak. So saya nak cari kat point ni kan. Lemak susah lah pula. So this is the point that I want to find. Kenapa dia tak kena? So at this point your acceleration is equal to 0. Sama je. Gradient is equal. The gradient of a velocity graph will give you acceleration. The gradient of a displacement graph will give you velocity. It all depends on the equation. So this will give you A equals to 0. Sorry, this is instantaneous. And this one, at this point, your A is equal to positive value. At this point, your A equals to negative value. This is your instantaneous acceleration. And the blue line is your average acceleration. Okay. Okay, kat sini cakap yang blue line ni average. Kalau yang purple line ni adalah instantaneous velocity. Okay, linear motion with uniform positive velocity. Linear motion with uniform positive velocity. Kalau dia cakap uniform velocity, maksudnya delta V is equal to 0, which means that acceleration is equal to 0. So back to your linear kinematic equation, V equals to U plus AT. Your A is equal to 0 sebab change in velocity tak ada, is uniform. So V equals to U. This is what it means. V equals to U. V tak berubah over time. When do we see this? We see this for Vx. Vx, Ux. The V does not change over time. This is how it looks like in terms of graph. Okay, and then we have the displacement. Kalau V equals to Ux over time, in the displacement graph, it looks like this. Vx. Okay, this is displacement and this is time. Okay, the gradient of this guy is V, and if you were to plot it in terms of velocity versus time graph, it basically is a straight line. Okay, sebab value dia sama at all points. Kalau value dia berapa kat sini? 1.2, M equals to 1.2 kat sini, M equals to 1.2 kat sini, M equals to 1.2 kat sini, M equals to 1.2 kat sini. Graph dalam velocity, M equals to 1.2 kat sini. Kita pakai balik value M kat sini, kita plot velocity over time. So this is the value that we get. It is constant over time. It is therefore a straight line. Okay, so I hope everyone is okay sebab laju-laju je ni. So what if we have a V equals to minus U? Sama je. V equals to minus u, basically you have a negative value. So this is 0.8, let's say. And this would translate in terms of displacement as negative gradient lah. So this is a straight line, but it gives you a negative gradient. This is 0.8 value, m equals to sama, gives you a straight line, but negative. Okay, and then we have a linear motion with positive acceleration. So tadi kita cakap pasal V straight line. Ni pun V, sorry. Yang ni V straight line, this is also V straight line. V straight line adalah, what do you call this? I don't know what to call it. So straight line kat V akan dapat macam ni lah. Straight line V negatif akan dapat line yang ke bawah lah. Okay, I don't know what to call it. And then if you have a velocity that is going up, right? The gradient, sorry, we're talking about displacement here. When we have a velocity that is straight, displacement akan rupa dia macam ni. Okay, because our equation V is no longer V equals to U, it's V equals to U plus AT. Maksudnya kat sini our V akan berubah. Kalau V equals to U sahaja, kita akan dapat straight line graph. This is V and this is time. This is V equals to U. But now if our A has value, it means that our V will change. So our V is changing over time. Therefore, kalau velocity kita changing over time, displacement kita lagilah berubah over time. So displacement kita jadi parabolic equation. It follows this equation. S equals to ut plus 1 over 2 at squared. In this case, A is not equal to 0. A ada value. Okay, so it follows this parabolic equation lah. The parabolic equation is downwards. And then if our A is negative, which we see in reality, our gravity is negative, right? If our A is negative, V equals to U minus AT, our S displacement will give us a parabolic equation, but now it's flipped. Now it's like that, and it's below time. Okay, so semua equation ni, dia boleh plotted in terms of graph. And if you don't believe me, it looks like this. You can put in the values yourself and try to plot it. Boleh buat imaginary numbers, buat number sendiri. And then for V equals to U minus AT, the gradient of our V should be a negative, right? So this is an M that is negative. Therefore, our acceleration is negative. The gradient for a velocity time graph gives us acceleration. Okay, okay. Kita akan go over the example, tapi tak cukup masa. Kita akan go over cepat-cepat je. Do you guys want a break or should we just continue sampai habis? Sikit je lagi ni. Ke dah tak boleh sangat dah? Do we need a break or can we continue? Continue sampai habis I think another 10 minutes kot. Kita go over example and then we are done with the subtopic. Okay, sikit lagi sikit lagi. Tahan tahan macam apa je. Okay, so example 2.9. A record of travel along a straight path is as follows. It starts from rest. Kalau kita cakap from rest, V equals to 0 with constant acceleration. A is constant, 2.8 meter per second squared. The time is 15 seconds. Okay, they start at 0. Acceleration is constant and positive. And the time taken is 15 seconds. Okay, so immediately the first number one, untuk number one dulu. Kita buat velocity time graph. Kita roughly sketch dulu to get an idea before kita buat betul-betul. From time 0 to 15, the acceleration is positive. I start from a V that is 0, so I start from this point. This is my V. For 15 seconds, it should give me a 2.8 meter per second of acceleration, which is my gradient. So immediately I know that my line should be like that sebab saya nak positive gradient acceleration. Tapi saya tak tahu value dia apa. So macam mana saya nak kira? I use my linear kinematic equation. V equals to U plus AT. I have my U, which is this guy, V equals 0. Basically, this is U because we started from rest. So it's a U. 0 plus 2.8. I have my time is 15 seconds. So my velocity is 2.8 times 15. That is a 42. 42. So dekat 15, this should be 42. Kita roughly sketch dulu So this is a 42. Okay, ni 42 walaupun rupa dia macam tu. Okay, and then constant velocity for the next 2 minutes. Constant velocity for the next 2 minutes. So constant velocity for next 2 minutes. 2 minutes is 60 times 2, 120. 120 plus 15, 135. So at 135 seconds, this guy is in seconds, this guy is in meter per second. Ni roughly dulu I would be at a constant velocity. So straight line. Velocity tak berubah. Acceleration is 0, gradient is 0. So daripada point yang pertama tadi, let's use a different color. Let's use pink. I would have this much, I would have this line, and for the next 2 minutes, I would have this straight line. This is T equals to 120 seconds. This is T equals to 15 seconds. Okay, sebenarnya saya tak payah tulis pun. I don't need to write this. I'm just showing it to you. Apa yang berlaku kat sini? Apa yang saya padam Velocity. Meter per second. Okay. So next, constant negative acceleration. Now I know that I need a negative gradient. Constant negative acceleration minus 3.6 meter per second. Minus, so A. My A is now minus 3.6 meter per second for 10 seconds. The time taken, the time for this negative acceleration, it happens over 10 seconds. So we start from this point and it goes on for 10 seconds. So sekarang ni saya tahu saya kena tambah masa sebab tak cukup tempat kat sini. Okay. So 135 plus 10 is 145. Boleh abaikan what do you call this? Scale dia. Tak seragam. So kat sini 15, 135, 145. Ni rough sketch tu dulu. Okay, time in second. So dia cakap and in 10 seconds dia ada negative acceleration. Time equals to 10, right? But we don't know what the velocity is. So I have to use my equation. So V equals to U plus AT. In this case, this is a new section of the motion. Our V is 42. Sorry, our U is 42 minus 3.6, and the time taken during this negative acceleration is 10 seconds. So 42, sebab saya start dari sini ke sini saya tak tahu final velocity dia apa, tapi saya tahu initial dia apa, which is 42. The time taken over here is 10 seconds and the acceleration is a negative. So I can solve for it. So 3.6 times 10 minus 36. 42 minus 36 will give me 6. So my final velocity is 6. So the way that I should plot this is 6. So anggap kat sini 6. Okay, so this is where we should draw the line. Okay, so this is what we got. This is A 2.8. This is A equals to 2.8. This is A1. Let's label this as A1. This is A2. A2, what was A2? A2 was 0. Constant velocity. A2 equals 0. This is A2 equals 0. Constant velocity means 0 acceleration. And then we went down, A3 equals to minus 3.6. This guy was our A3. So we divided this motion into 3 parts. Memang soalan dia dah siap-siap divide untuk kita, so that we could solve for the motion. So now it's asking what were the average speeds at each stage? 1, 2, and 3. What is the average speed for the whole trip? What was the total displacement for the complete trip? Sketch the velocity time graph. So we already did this one, kita sketch. But now they want to know what is the average speed dekat sini, nombor 1, nombor 2, nombor 3. Average speed for the whole trip, maksudnya daripada final to initial, daripada sini ke sini, what is the gradient? They want to know what is the, it's asking for average speed, bukan. So divided by 2 je lah. Final plus initial divided by 2 will give you the average speed. Or just use linear kinematic. What was the total displacement for the complete trip? Use S. Okay, so let's see. This is not the answer kan? Is it the answer? Where's the answer? This is example 2.9. Terkejut saya. Okay, dia buat macam ni. Kenapa lain? Example 2.9, 2.8 meter per second. This is not the question. Okay, this is the one. This is example 2.10. Oh, salah label. Okay, so kita sketch our velocity time graph, and we got like this, and then straight line, and then ke bawah. So sama. So soalan dia sekarang tanya, what were the average speeds each stage 1, 2, 3 of the trip? So dekat sini dia buat the straight line yang kita belajar in linear motion. U and then V1, V2, V3. This is A, A2, A3. Kita tahu ni. Time is 15 and then 2 minutes over here and then 10 seconds. Kita tak tahu S dia apa kat sini. So dia tanya, what were the average speeds at each stage? So the final velocity at stage 1 was 42. Yang ni kita dah tahu. Kita pakai linear kinematic, V equals to U plus AT. And then the displacement, we found out that kita kena cari pakai linear kinematic as well. S equals to UT plus 1 over 2 AT squared. In this case, our U, we started at rest, 0 times 15 plus 1 over 2, 2.8. But kat sini 2.8. And then 15 seconds. So kita dapat displacement dia as 315. So to find the average speed, kat sini ada. To find the average speed, we have to know what is the displacement and then we divide it over time. Ataupun kita tambah 0 tambah V1 divided by 2. It will give you a roughly same answer, but the most accurate equation to use will be using displacement over time. I know it says speed, tapi kat sini our distance is displacement for this section. Okay, so kita boleh pakai. So 315 over 15. This is the displacement over this duration, S1. Kita solve for S1, right? S1 is from here to here. What is the average speed? S1 over time. S1 is 315 divided by 15, you get 21 meter per second. So what if I wanted to use the other equation? Let me see. Would it give me approximately the same? 42 divided by 2, I get 21. Lebih kurang. Bukan lebih kurang, sama. So boleh pakai V plus U divided by 2. You get average speed. You get, this is the equation. But most of the time dia akan kasih jawapan yang tak berapa accurate. Dia kasih approximation sahaja. So I would recommend to use equation displacement over time to solve for average speed. So and then for stage 2, sama je. We have the final velocity which is equal to the initial velocity. Remember we had a straight line for this guy. Velocity, change in velocity is equal to 0. This is A. V1 is equal to V2. So displacement adalah S2 equals to V1 T2 Okay, just plug in the values lah. So you get 5040 meter. Sama juga 5040 divided by 120. The total duration of time for section 2. So you get, apa tak boleh, oh dia kat tempat lain. So you get 24. Where's stage 2? Oh bawah ni, sorry. So you get, tak ada. 5040 divided by 120, the average speed is 42. Okay, because dia tak berubah, so you basically get the same answer. But I wanted to show the jalan kira, meaning to say if you're not sure, just use the equation. And then for stage 3, let's look at stage 3. We started with V1 as, our V2 as our initial velocity, which is 42. Remember, it's a straight line. And then kita ke bawah macam tu kan. V3 kita adalah 6 ke tak silap. I think it was 6 earlier. Yeah, we got 6. Okay, so the final velocity we solved as 6. Kita nak cari displacement for stage 3. Okay, displacement is S equals to UT plus 1 over 2 AT squared. Just plug in the values, you will get 240. 240 divided by 10, dapat 24. Okay, so the average speed for the whole trip, you will have to find out the total displacement, S1 plus S2 plus S3. Okay, and then you will get this total and then divided by the total time, you will get the average speed for the entire trip. This is how you calculate for the average speed. And then for the total displacement, sama je lah. Okay. So what is the total displacement for the complete trip? Okay. So I think this is basically what we got. And we use linear kinematics to solve at each stage. So any questions about this one? Dah habis dah sebenarnya. Ada tak soalan pasal ni? Faham ke? Kalau tak faham kena tanya. No confusion? So everyone's okay with the equations that we used and how we got this graph? Okay, faham Okay, let's see. So I'm going to leave you guys with this question. Saya tak tahu kot nak suruh korang buat ke tak. Tapi web assign ada juga soalan ni. So tak payahlah. Buat je lah web assign . Kalau ada issue, you don't know how to do it, you can ask me. Okay, so basically web assign punya soalan akan rupa dia macam ni lah. Tak berapa senang, tak berapa susah. You can do it. We already did this in class. So just remember, if you have a straight line, gradient is equal to 0. It doesn't matter if it's, kalau kita ada velocity time graph, a straight line would give us A equals to 0. This is a velocity time graph. If we have an displacement time graph, okay, xt, a straight line would give us V equals to 0. The gradient of a displacement time graph is velocity. The gradient for a velocity time graph is acceleration. Kalau positif, menaik macam ni. Kalau macam ni, V positif. Turun macam ni, V negatif. Turun macam ni, A negatif. Okay? It's simple. Jangan rasa serabut lah pasal benda ni, okay? And then take note of the time, duration, divide your motions into sections. Use this one. Mana? Use this guide as a guide. Lukis the straight line graph before you start plotting. Okay, I should have done that, but I forgot. Okay, so I think that's it from me. Take care, everyone. Sorry it took longer than what I predicted. I hope you guys understand chapter 2 because we are finished with it. Please do your web assign. It's already up for chapter 2. So take care. Have a great rest of the day. Bye-bye, guys. Semua orang dah macam larat dah. Bye-bye.
Thank you, Doktor.
Thank you,
Doktor.
Betul.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doktor.
Welcome. Bye-bye.
Doktor nak tanya group eksperimen ada berubah ke? Sebab Izrin, grup saya Izrin dah keluar dari Expo.
Oh, okay. Siapa lagi keluar? Thank you. Saya lupa pasal ni. Siapa lagi yang keluar dalam kelas ni?
Rasanya Izrin je.
Izrin je. Okay, nanti saya akan tengok kalau ada group yang ada 4 orang, saya akan masuk ke dalam group awak. Kalau tak, please proceed with your current group, which is 2 orang je lah buat masa ni Okay, nanti saya tengok balik Thank you.
Thank you, Doktor.
Okay, welcome. Bye-bye.